Hello there, friends of natural history. I'm Bob Ellis, bringing to you another edition of Notes from the Field. I'm out here with James Holder, our collection manager, and we are on the Upper Verde. The Upper Verde, where we're located, happens to be in the northernmost part of the Mogollon Highlands. And what we're interested in talking about today is this forest that's behind me. And according to David Brown, Biotic Communities of the Southwest, he classifies this biotic community as the interior riparian deciduous forest. And there's some very fascinating facts about this forest that we wanted to share with you and show you today. The first one is that what a wonderful place to be while we're out in the hot sun. And the shade that it casts, nice and cool, enjoyable place to be on a hot day. This landscape wasn't always a hot landscape. If you turn back the clock about 10,000 years ago, during the beginning of the interglacial, as the glaciers began to retreat, this particular part of North America was relatively, by comparison, much colder. And the dominant vegetation, if we were to look in the landscape in the uplands, would be pines, maybe even some spruce, some fir. And now, of course, the uplands much drier, much hotter. However, the organisms that were successful in those well-watered or mesic areas at that time retreated. And they retreated to the riparian areas such as this place today. And so you can think in a lot of ways that this riparian forest is a relic. It's a relic of years gone by, and you can think of this forest as a refuge, that this is about the only place in this dry, hot landscape where these plants and this community can flourish. So I wanted to share with you some of the characteristics of the forest and some of the species in it. One of the ways you can think about this forest is a production engine. There's tremendous amount of biological productivity going on down here because these plants have access to water, whereas in the uplands, as we will see in a moment, there's just not that much productivity up there. What do I mean by productivity? Well, what I mean is biomass being produced over the course of the year. So we're talking about leaves, trunks, and stems. There's a tremendous amount of that happening down here, once again, due to access to water. What are the species down here that are dominating this landscape? Well, one very dominant species is this one. And this is a cottonwood. It's Fremont's cottonwood, or Populus fremontii. And as you look at that plant, you can see that it's very tall. And that's one of the characteristics of all the plants in the riparian area, is that they are trying to be anthropomorphic. They are trying to get up and above everything else around them because they're not competing for water, they're not competing for nutrients. What they are competing for is sunlight. So the idea here is to get up and over your neighbor so that you can get access to that sunlight, because access to that sunlight is the key to success down here in this streamside community. Another plant that is down here, and also in the same family as the cottonwoods, the willow family, is this willow. And it has the characteristic kind of willow leaf whenever we think of what a willow leaf might be. This one's Gooding's willow, Salix goodingii. And it too, one of its characteristics is to get as tall as I possibly can, as quick as I possibly can. And the way to do that is put on foliage, capture sunlight, turn that sunlight into energy and cellulose, and grow. Another plant that's down here, not as dominant, but nonetheless a plant that will, in some reaches of this streamside community, be very dominant. And this relatively short tree, and this one's convenient, there are others that are large, and maybe we'll find one in a moment, that has this compound leaf. Let's see what a compound leaf is. Whenever I pull the leaf off of the stem, this is what I get whenever I do that to a cottonwood. Whenever I do that to this ash tree, whoa, it looks like I got a bunch of leaves. But in reality, this is the leaf, and these are leaflets. And this, once again, kind of fits the scheme down here, which is to get as much foliage exposed to the sun as you possibly can, and get the sun's energy, capture it, and turn it into a vertical height. This plant is Fraxinus velutina, or velvet ash, and it's the most common ash here in the Mogollon Highlands. So back to the name of this biotic community, interior, riparian, deciduous forest. You can hear the stream nearby. So all of these trees have their roots in water year-round. And that's the key to their success down here. The fundamental challenge that all plants face is the challenge of keeping the stoma open to capture carbon dioxide. And if you remember, the capturing of carbon dioxide is critical to plant growth because that's what they make carbohydrates out of. But if you leave your stoma open, you're losing water. So these plants solve that problem by leaving the stoma open all the time because they have plenty of access to water. And with that plenty of access to water, they have plenty of access to carbon dioxide and therefore growth. The fact that they're deciduous is also advantageous because the photosynthetic process, as a biochemical process, can only proceed efficiently at certain temperatures. So the strategy that has evolved in this interior riparian deciduous forest, like in all deciduous forest, is to capture sunlight when the air temperature is sufficient to propel that photosynthetic process, and then become dormant during the rest of the year and save those resources for the next time the air temperature is warm enough and sunlight is abundant enough to be productive. And so I know I painted this scenario down here in this biotic community of one of pure competition. And that's not exactly true, because there are other things going on here outside of competition. There are other interspecific relationships that were worth focusing on. Because this is one of the most productive biotic communities that there are, there's a lot of biomass being produced, and there's a lot of biomass being produced that we don't see. And that's happening down in the rhizosphere, or the root world. Down in root world, there is intercommunication between all of these species that's facilitated by fungi, mycorrhizal fungi. And these are fungi that have evolved to be able to engage in a mutualistic relationship. That means that both species benefit and thrive as a result of that mutualism. So in the case of these mycorrhizal fungi, they are capturing nutrients such as nitrogen and phosphorus, channeling those to these plants which need those nutrients, and the mycorrhizal fungi get the benefit of exudate or photosynthate. So it's hard to imagine, but these enormous trees below ground have an almost as enormous system going on. Part of that system has evolved to produce exudate, and that is sugars that are released through the roots to feed other organisms. And quote unquote, to feed sounds like it's altruistic, but there's a competitive advantage in these relationships. For example, a competitive advantage in feeding organisms around you would be this fungus, this mushroom, which is the fruiting body of a mycelial mass, which is this enormous mass of very small white bodies that are beneath the ground. This organism is very busy decomposing all sorts of organic matter that has fallen from these trees and turning that organic matter once again back into nutrients such as nitrogen and phosphorus that enriches the forest, subsequently enriches the forest. So that is definitely some mutualistic elements to this, what I painted as a predominantly competitive sort of community. So I'd like to say quite simply that water in the arid Southwest is magic. This relic community has retreated from an ice age some 10,000 years ago and finds itself in this narrow little canyon, which if we viewed from above would look like a thin green vein stretched across a parched landscape. And so in many ways, not only is this a relictual community, but it's also an imperiled community. As the Southwest population grows, human population grows, and as climate tends to get warmer and drier, streams like these and communities like these are imperiled. And so I think it's important that we all recognize that what a treasure we have in rivers like the Verde River, and how we might think about ways in which we can conserve them. So thank you for coming along today on this little trip we've taken down into this interior riparian deciduous forest. I'd like for you to hit that subscribe button down at the bottom of your screen. We have many more of these videos on our YouTube channel and many more planned, and we'd like for you to come along with us. If you really like what we're doing, why don't you go over to our website, and that is naturalhistoryinstitute.org, and find that donate button on our webpage and click on that and help us kind of get the message out about communities like the interior riparian deciduous forest. Thank you.